Today we're going to review how to set up and conduct a calorimetry lab. There's several pieces of equipment that you need. Again, most of these should be at your lab station. First and foremost, you absolutely positively have to wear your safety glasses for this lab. That's a non-negotiable. So I'm going to put those on right now. Now, the rest of the items you need include a ring stand. The ring stand should have a small Erlenmeyer flask with this collar on it, and the collar is intended to suspend the Erlenmeyer flask over whatever it is that you're burning. The idea is in calorimetry that the heat from the food that's burned is transferred to the water, and then we can detect changes in temperature, which is an indication of the number of calories in the food. So this ultimately sort of dangles over the food on the ring stand, but we have this piece of metal. It's like a sleeve or a collar, and it fits over the brass fixture that holds the Erlenmeyer flask. In other words, you just kind of slide it over and then turn it 90 degrees, and then voila, you have your Erlenmeyer flask suspended. I'm going to take this out right now because one of the first things you're going to do in this experiment is actually get the mass of the water. You need that in your calculations. So I'm going to leave that aside for right now. Attached to my ring stand is a thermometer. It's actually a probe. It's a vernier probe for detecting temperature or measuring temperature. And then, of course, attached to this probe is the Go link, which will connect to your laptop. So it connects the probe to your laptop. You really want to make sure that these cables are all out of the way. I actually sort of tuck them in behind the apparatus in the ring stand because you don't want burning food next to the cable connected to your laptop. Next, you have a lighter for obvious reasons. You also will find a piece of clay with a paper clip on it. This is kind of a stump that we're going to use to kind of impale the food. In this case, I have red licorice. I actually didn't have any of the foods that we're going to use in this lab, which are marshmallows or Cheetos. So I'm just going to use whatever I had in my desk for a snack today, which is a piece of red licorice. I don't know if it burns or not, but you basically mount the food on this peg, on the paper clip with the red clay or whatever color clay you have, and that holds the food in place. Now you also need to measure the mass of the food before you put it on the stump. That's another measurement that you need. So before you place the food on the stump and before you place the stump on the ring stand, you need to measure the mass of the food. Next, you have a chimney. It's got this little wedge cut out. That's so you can place the chimney over the food. This way, any of the heat that's produced by burning food mainly goes up the chimney and into the water, so it kind of minimizes heat loss. There's always going to be some heat loss, but you want to minimize it, and you want to sort of angle that little cutout towards you so you can get the lighter in to light the food. You don't want to be trying to light the food like that. So, assuming that I have got the mass or obtained the mass of the water, I'm going to place my Erlenmeyer flask over the chimney. You can actually lower this a little bit if you want to bring this closer to the food to minimize heat loss. That's fine. And the other measurement you need in addition to the mass of the food and the mass of the water is obviously the starting temperature of the water. Now to do this, you'll need to loosen one of the clamps that holds the temperature probe in place, and you're just going to lower this into the Erlenmeyer flask. Now it absolutely positively has to be in the water for it to be measuring the temperature of the water, so it can't dangle above the water, and if possible try to avoid touching the bottom of the Erlenmeyer flask with the end of the probe. That can also affect temperature measurements. Once you now go to Logger Pro or Logger Lite on your laptop, open it up. If it's connected through the USB port, it should automatically detect that this is a temperature probe and it should begin temperature readings. you need also to record the beginning or initial temperature of the water. So you may want to lower it in and give it a minute or so to calibrate. Now for the fun part. At this point, once everything is ready to go, and only once everything is ready to go, you can light the food. Again, I'm not sure if this will light or not, but essentially you just get this going. And it's not burning particularly well, but it's burning a little bit. And what you want to do is let the food burn. There's not an exact amount of time, and the actual amount of time doesn't matter. We sort of control for this in our calculations. But you want to let a good portion of the food burn. In other words, to liberate enough heat that you're able to detect it. You don't want to try and get like a huge Cheeto bonfire going. The Cheetos really burn quite well. So once you get the fire really going, you can extinguish the flame simply by blowing through the little notch that you use to light it. Blow it, give it a nice hard puff, and that should extinguish the flames. And then let the smoke come out. And the last thing that you need to be aware of is that you will see the temperature will continue to rise after the flame is extinguished. There's some residual heat, and the water will continue to slowly change temperature. So watch for it on Logger Pro. You'll sort of see the temperature go up and up and up, and then it'll start to level off. And once you detect no more increase in temperature, that's the final temperature, and you need to record that. Finally, once you break the apparatus down, the last thing that you need to do is to take the burned food and put that in a weigh boat and calculate the final mass of the burned food as well. So that's one of the final measurements that you need to take is the burned food. Last but not least, please always clean up your lab station. Remember, of course, even though you're burning marshmallows, we cannot make s'mores, so don't bust out the graham crackers and chocolate. That is considered hazardous waste since it's now being used in a chemistry lab. So take the food and throw it in the trash. And then if there's any mess here, that'd be great if you could clean that up. If you've got a lot of soot on the Erlenmeyer flask, if you could run that under the tap and scrape all of that off or rub it off with a Brillo pad, that would be great as well. The more you can clean up, the better it will be for the next group of students to do the lab. You can also then repeat this for the remaining 2 food items. So if you started with the Cheeto, you also need to do the corn oil, and you also need to do the marshmallow. So do all 3, and to do that, you probably want to change the water between trials, and again, take all of those measurements again, the initial temperature, the initial mass of the food, the final mass of the food, the final temperature of the water, and be sure that you have all of those things recorded in your data table, or else you'll have to repeat one of the trials.